Students, today we'll discuss another important topic in STLD subject. In the STLD subject, we are discussing some series of topics. In the last class, we discussed about Mealy to Moore conversion with example. Now we'll discuss another most important topic in especially JNT exams for both the EEE and ECE people. Now the important topic is Moore to Mealy conversion. In the last class we discussed about Mealy to Moore conversion. Today we'll go for Moore to Mealy conversion. Very easy concept. In easiest way we'll discuss this within short time. This is the given problem. Prime state, ns is the next state and z is the output. When x is equal to 0 for state A, what is the corresponding output? And when x is equal to 1, what is the corresponding output? Next state and output. These are the next states and z is the output. A is the prime state. When x is equal to 0, next state is D. When x is equal to 1, next state is B. Output is 0 and so on. Like that we have how many states? 4 states we have. A, B, C, D. 4 states. After giving the problem, first we have to check whether is there any same states. Same states is nothing but in these 4 states, any state is having same output. First we can check that. So here I am observing the state A. State A is having 0, state B is having output 1 and state C is having output 0 and D is having output 0. Here A is having 0 and only B is having one output, different output, remaining all are same outputs. So for the same output states A, C and D, is there any same next states? You have to check. My intention is you have to check next state comma output, both same next state comma outputs are how many there in the given problem, that we have to check. See here A is having D, B and output 0. Same like that A, if there is any state you have to check. B, C and output is 1, this is not same. C, D and output 0, this is not same. And D, B and output 0. D, D, B, B, 0, 0. Nothing but A and D are same next states and same outputs. If any states are having same outputs, same next states and same outputs, those states are called as equivalent states. So A and D are having same outputs as well as same next states. That's why so A and D are equivalent states. Equivalent is nothing but A is equal to D. In place of A you may write D, in place of D you may write A. So that is nothing but A is equal to D. When A is having next state D, B and 0 and D is also having D, B and 0. That's why A and D are same states, then A is equal to D. Like that you have to observe for any number of states. And here in place both are same states, that's why in place of 4 states you may eliminate whether A or D. Any one state you can eliminate. In this example I am eliminating D. So these two states are same, that's why no need to write again the same state. That's why reduced table is like this: prime state, next state and output. Same table I am writing. A as it is I am writing A, D, B 0. Generally here D same I am writing D, B same D, and here we have C state. This is a D. Generally we have D. From the table in place of A and D I am eliminating this D. Remaining table I am writing. So up to ABC I am writing. Up to ABC I wrote DB 0, BC 1 and CD 0. See here we know that A is equal to D. That's why in place of D we are going to substitute A. Why? Because we are eliminating D. That's why in place of D you have to write A. Which one we are eliminating, that you can don't write. So A, next state is D. But what is D? D is A. You can write A. In the same manner, is there any D's? You can write in place of D A. Yeah. This is the reduced table. First, for the given problem, reduce the number of states. Is there any possibility? then you can write the reduced table. Then from this we have to convert into the Mealy machine. For that, what we have to do is you can write the corresponding outputs first. So without writing separately also we can able to draw the final table, but for the easiness you have to write corresponding outputs. For A, what is the corresponding output? 0. A output is 0. This is for A state, output is 0. And for B state, what is the output? 1. For B state, output is 1. For C state, output is 0. These outputs you may write for the first table also, no problem. Both are same. So that's why I wrote D also. Actually D is no need. If you write outputs first for all states, then output of the D is 0. Output of the D is 0. That's why no need to write. So here A is equal to D. That's why you may eliminate this one. We have A, B, C and corresponding outputs. Then go for the Mealy machine. We have to write the final machine, that is a Mealy machine. Write the prior states as it is, ABC as it is. And here we have to write a Mealy machine as next state comma Z. So next state comma Z we are writing when x is equal to 0 and x is equal to 1. Same states you can write A, B, B, C, C, A. A, B, B, C and C, A. So next state comma Z we are writing in Mealy machine. Next state comma Z we are writing. Next states are not changing. Same. A, when x is equal to 0, next state is A. When x is equal to 0, next state is A. For A, when x is equal to 1, next state is B. Next state B. Next state is B. In the table as it is, these two columns as it is you can write. As it is you can write. And what is the corresponding output? Next state comma output we are writing. So output is from this. For A, what is the output? In next states, if is there any A, that corresponding output you have to write like this. For A, what is the output? For A, what is the output? 0. So A comma 0. A comma 0. And next state is when x is equal to 1 for A, next state is B. For B, what is the output? For B, what is the output? 1. You can write 1. And in the same manner, state B, when x is equal to 0, the next state is B. For B, what is the output? Just now we saw, this is 1, output is 1, B comma 1. In the same manner for B, when x is equal to 1, what is the next state? C. For C, what is the output? For C, what is the output? 0. 0 you can write. Then go for the last state similarly, C, and corresponding output is when x is equal to 0, corresponding next state is 0, C. C. For C, what is the corresponding output? 0. C comma 0. If the state is C, when x is equal to 0, the next state is C, and the corresponding output is 0. For C, what is the output? And same manner, when x is equal to 1, for state C, what is the next state? A. For A, what is the output? 0. So this is the Mealy machine. Like this we can convert from Moore to Mealy. Like this you can practice more examples. This will become very easy. Okay. For state excitation table, in the same manner for state transition diagram, you may do the same. For the state transition table also, transition diagram also, or state diagram also, you may write the same way. So this is a Moore to Mealy conversion. This is a compulsory question. Go through this one and take this screenshot. If you have any doubts, you can comment me on comment box. Thank you.